This week we'll be talking about the slope of a line and the slope-intercept formula. We'll start out today with an introduction to what slope is. Slope is defined as the slant or tilt of a line, and that can be measured quantitatively by finding the difference between the y values, as in the numerator here, or the difference between the x values and a ratio of those. Frequently we call the difference between the y values the rise, and the difference between the x values the run. And we have to be consistent here, where we go from the second ordered pair minus the first ordered pair. So it should be y2 minus y1 over x2 minus x1. And I talked about rise and run and using these exact same differences in the x's and y's when we were talking about the distance formula. So you may want to go back and review that. Just as a quick visual example here in my picture, let's just suppose that these ordered pairs were at 3, 2, and this other one was, I don't know, let's say it's 7, 5. One way to calculate the rise and run would be visually to look and see how much would you need to go up from the first ordered pair, the 3, 2, to get to the second ordered pair, the 7, 5. In order to go from 2 to 5 on the y-axis, we would have to rise 3. And that can be found from calculating what the rise is. So m is equal to y2 would be 5 minus y1 would be 2. Okay, and that would tell us that the rise was 3, or in other words, I needed to go up 3 units for the rise. The run could be calculated the same way, and again we have to go from the second ordered pair and subtract the first one. So I would set up my x2 value, which is 7, and subtract the x1 value, which is 3, and there I'd get 4. This means that the slope of the line that passes between those 2 points is 3 over 4. So here's our example problem where we don't have a graph, we just have the ordered pairs, and we're trying to find the slope of the line that passes through those 2 points. There's a systematic process to follow this. It's kind of like what I explained for solving a distance formula problem with these steps. First we will label the coordinates. By labeling the coordinates, what I mean is we're going to write in x1, y1 for the first ordered pair. So my -2 is x1, my -3 is y1, because that's the x and the y coordinates from the first ordered pair. That's what the 1's denote. My 4 is going to be x2, and the 6 is going to be y2. The 2 is again denoting that the 4 and the 6 come from the second ordered pair, and x and y being the x and the y coordinates of that ordered pair. So now I have labeled my coordinates. Next I'm going to write down the formula. The slope formula, as we saw before, was rise over run. Rise can be calculated by subtracting y2 minus y1. The run in the denominator can be found by x2 minus x1. Next I'm going to draw the framework of that formula, or what I've sometimes referred to as the skeleton. This would be with blanks where numbers go, but the minus sign should be there because the formula has those minus signs. That would look like this. Okay, I have tried to make this still so you can tell what numbers go where, but I'm going to be writing over those values now. So now I need to substitute the values into my framework where these kind of washed out numbers are. And so this is the substitute step. So substituting my values for the y's, notice that all of the letters and numbers and everything here have been color coordinated. So my values in the numerator should come from the y's. y2 being this 6, so I plug a 6 in. y1 is this -3, so I plug in a -3 here. Notice again that I've got minus signs that are right next to each other like that. That's going to change into a plus sign when I do the simplify step. In the denominator I've got these red values, so my x2 is the 4, So I substitute that here, and my x1 is this -2. And again, I've got minus signs right next to each other. Again, important in the simplify step, which is what I'm on now, is the simplify step. So I'm going to simplify the expression, and I'm going to rewrite 6 minus -3 as 6 plus 3, and I'm going to rewrite 4 minus -2 as 4 plus 2. This is going to then simplify. 6 plus 3 is 9 in the numerator, 4 plus 2 is 6 in the denominator. Oh, that fraction reduces, so if I divide top and bottom by 3, or the way I like to do this is, let's rewrite this as 3 times 3 over 2 times 3. I've got a 3 reducing out of the numerator and denominator, leaving me with the fraction 3 over 2. This then is the slope of the line that passes through those 2 points. I think one example is probably enough, since you can go back and rewatch my explanation if you need to. And these problems are very similar to the distance formula problems that we've done already, where you're following that 5-step procedure to set up the problem and solve it, or simplify it. Here are the 2 problems that I'd like for you to work by yourself today, and we will transfer these answers into our warm-ups tomorrow. Good luck, students.